Hello guys, hope you are all doing extremely well. In this video, I am going to solve this problem of the day from Leetcode, and today's problem is search in rotated sorted array. This problem has its previous version, which is search in rotated sorted array 1, and the approach of this problem arrives from its previous version. So if you have not solved its previous version, solve it. And I have recently uploaded a video about search in rotated sorted array 1. Was that, then come back again here, and then definitely you will understand it in a better way. Let's get started. There is an integer array num sorted in non-decreasing order, not necessarily with distinct values. Here we will give an array nums, and it can have duplicates, and its previous version has all the array elements as distinct. And here also we'll see rotation before being passed to your function. Nums is rotated at some unknown pivot index. And here we have given array nums and integer target, and we have to find that if target is present in our array nums or not, and we have to return true if it is present, and we have to return false if it is not present. Let me briefly talk about its previous version, search in rotated sorted array 1. What we were doing here, I am taking an array with distinct values and sorted to 1, 3, 4, 8, 10, 11, 12. This is the sorted array with distinct values. Now I'm going to rotate it. Let's rotate it through here. So 8 will come in the starting, and then all the remaining elements the same order. 10, 12, sorry, after 10 11 will come, 11, 12, then we'll start from starting, and we'll take remaining elements in the same order, 1, 3, 4. This is the array after rotation, and this is rotation. All this explained here. The pivot index is k. This is the pivot element, and pivot element comes at the starting till the last element. Here I have done the same from pivot element till last, and then we'll start from the first element till remaining elements, and I have done same here. And this rotation was also present in its previous version, search in rotated sorted array 1. How we were doing that problem? We were searching for the sorted part. We were trying to apply binary search here. We are trying to discard one of the part out of this array, and focus our search only on the one part after dividing. Let me write indexes here: 1, 2, 3, 4, 5, 6. I have told you that definitely there is going to be two parts, and one of them will be sorted if I have rotated the sorted array with distinct values. And we can clearly see that 8, 10, 11, 12, this part is sorted, and this is not, because whole array was sorted. I have placed some of part from the back to the front, so there only one part where the order is broken. Here the order is broken. So if I divide it in two parts, surely one part will be sorted and other will not be sorted. So after finding the sorted part, we were finding that if our target is present in the sorted part or not. Let's say here our target is 10. If it is 10, then I will search that if it is present in this range from 8 to 12 or not. It should be, target should be greater than equals to 8 and less than equals to 12. Yes, 10 satisfied this condition. So I will discard the remaining elements. I will focus my search only on this part. And this is the concept of the binary search. So we have done this problem by a search in rotated sorted array 1 through the modified binary search. Now if my target were 3, then definitely 3 cannot be present between 8 and 12, and definitely it is going to be in the right part. So we'll eliminate this and we'll focus our search on this. This will reduce our search space at each step. So this is how we were solving search in rotated sorted array 1. We can use this approach for solving this problem too, search in rotated sorted array part 2. But we have to make some changes. As the difference here is that elements can be duplicate and we don't have to return index. In previous problem we have to return the index after finding it. Here we have to just find that if it is present or not. Now let me take a example of array which is containing some repetitive value. 1 3 3 3 3 3 lot of threes. This is the array initially, and then let's rotate it from here. So all the elements from this 3 till last will come, and there are 1 2 3 4 5 threes. 1 2 3 4 5, and then these remaining 2 will come from starting 1 3. Let me write indexes here: 0 1 2 3 4 5 6. Now in this case this is the mid index. Here if we try to find out the sorted part, we cannot do that because this is our starting, this is our mid, and this is our end. But values at starting, mid, and end all are same. Then how can we find that which is the sorted part, where the left is sorted part or right is sorted part? Here we cannot decide. Here we can see with our eyes that this is not sorted because one is present in between. But in program, how can we find that this is sorted, this is not sorted? So in this case, if we manage this case separately, the problem is same as its previous version. So what we are going to do, before checking the sorted part, first of all we'll check if all these three elements are same. If they are same, we cannot find the sorted part. We'll just move start one place ahead and one place back. And first of all, before comparing these start, mid, and end, we'll check if this mid is equals to our target or not. If it's already equals to our target, then we'll return true. If it is not equals to target, then certainly these two will also not going to be the target. So we'll move start and end by one place. Start will come here and end will come here. Now again we will check. There can be a case when again these three values can be same. Suppose if one was present here and 3 was present here, then again these three values are same, and again we cannot decide which is the shorted part. Then again we will follow the same procedure. We'll move ahead start and we'll move ahead end if this is not the required element, and then again we will search for the shorted part. So the only change we have to do is that we have to only explicitly search about this condition when these three elements are same. If they are same, then we'll move ahead start and end by one place, and after moving we'll continue. We will Why I'm doing this continue, I'm skipping the current iteration, because after that if we check for the sorted part, there can be a condition that again they can be same. So again we have to check this repeatedly till they all these three values are not same. Then when all these three values are not same, then we can find the sorted part. After finding the sorted part, the procedure is same as the previous problem. We will find if the target is our range of the sorted part or not. If it is in the range, then we will discard the other part, and see in the sorted part. If it is not in the sorted part, then we'll discard the sorted part and see in other part. Now let me code it and it will become more clear to you. I will start with declaring start and end variables. Start initial will be at 0 and end initial will be at the last index, which is going to be nums dot size minus 1. Now I will apply while loop, which will be a typical binary search while loop, and as regular while loop works, it will work till start is less than equals to end. And in this while loop, I will find out mid as we do in binary search through the formula start plus end divided by 2. And after finding out mid, I will check if this mid element nums mid is equals to our target or not. If it is equals to target, we need not to do anything. Simply we will return true. We have found the required element. We will return true. Yes, it is present in our array nums. If it is not present at the mid index, then we'll search for that condition that I have mentioned, that if these three elements at starting, mid and end are same or not. So I am checking here, checking the condition when all three start, mid and end are same. I will check through this if condition if nums mid is equals to nums start, and at the same time this nums mid is equals to nums end. And what I have to do here, when this condition becomes true, then I have to move the left, that is start and end, one places towards mid. So I will do start is equals to start plus 1, and is equals to end minus 1, and then I will do continue. I will keep on checking till these all three elements are equal. So I have written here continue statement. If it is not the case, these three are not equal, then definitely I'm going to find one shorted part. So for finding out that shorted part, I am putting here if condition if nums start is less than equals to nums mid, means the left part is shorted. If left part is shorted, I will search if the target element is in the range of the left part through this if condition. If target is greater than equal to nums start and target less than equals to nums mid, then I will discard the left part and discard the right part, and I will focus my search on the left part of the array. And for doing this, I will change my end pointer and will become mid minus 1. In other condition, I'm going to discard the left part and focus my search on the right part, and my start will become mid plus 1. Now in the other case, left part is not sorted. Here left part is sorted, and in other case right part is sorted. And when right part is sorted, I'm going to search for the target element in the right part first. If target is greater than equal to nums mid and target less than equals to nums and then I will focus my search on the right part and I will discard the left part. For discarding left part, I will do start is equals to mid plus 1, and in the else part I will discard my other part and I will do end is equals to mid minus 1. And if it is not present in my given nums array, then control will come out of this while loop, and here outside of this while loop I will return false, because if it had been present in my nums array, then definitely at any step this return true condition will execute and I will not come here in this condition return false. Now the code is completed. Trying to run it. Yes, it is working fine. Let's try to submit it. Yes, it is submitted successfully. It is working absolutely fine. Hope you understood the concept of this problem. And this is it for this video, and I'm going to see you in the next video. Till then, bye bye, take care.